my dear lovely viewers. Good day to you all. You're welcome to today's class. So, um, the series continues for our gas laws. We've discussed at the beginning the boys' law, we discussed the child's law. So today we shall discuss the general gas law. For Boyle's law, we deduce the relation from the law which states that the volume of a given mass of a gas is inversely proportional to the pressure provided the temperature is kept constant, and the mathematical relation is V is inversely proportional to P. That's for the Boyle's law. While the Charles law states that the volume of a given mass of a gas is directly proportional to the temperature provided that the pressure is kept constant. And the mathematical relation for that is V is directly proportional to T. Putting these two relations, we have this V inversely proportional to P and directly proportional to T, right? So this is the same as saying that V, now introducing the constant sign, is KT over P. So this is the same as saying that PV is equals to KT. From here, making the K the subject of formula, we have the K is equals to PV over T. So this is the same as saying that P1V1 over T1 is equal to P2V2 all over T2. So this is the relation for the general gas law. So with this, we can easily solve this question given to us, which says that a given mass of a gas occupies 850 centimeter cube at 320 Kelvin and 0.92 times 10 raised to the power 5 Newton per meter square. So we are asked to calculate the volume of the gas at STP. STP stands for standard temperature and pressure. So all we need to do now is to bring out the parameters given in this question. The parameters will guide us to know which of them is unknown. We have to find using the relation we have disclosed first. So let's bring out the parameters. So we have that the given mass of a gas occupies 850 centimeter cube. From the unit centimeter cube, we know that this is the value for the volume. So this is the value for the V1 at T1 equals to 320 Kelvin. At the P1, which is pressure, is 0.92 times 10 raised to the power 5 Newton per meter square. So now we have to calculate V2, which is the pressure at STP. And at STP, that is standard temperature and pressure, the value for the temperature is 273 Kelvin, while the value for the pressure, that is P2 here, is going to be 1.01 times 10 raised to the power of 5 Newton per meter square. So having all of these parameters, all we need to do is to substitute these parameters into the relation we have up here and make our calculations and get the final correct answer. So we have the P1 V1 over T1 is equal to P2 V2 all over T2. So in this, we have to find the value for V2. So let's make V2 the subject of formula here. So we have the P1 V1 T2, that's when we'll cross multiply, is equals to P2 V2 T1. So making V2 the subject of formula, this gives us V2 is equals to P1 V1 T2 all over P2 T1. So now with this relation, we can substitute in the values given and get the answer. So here we have that V2 is equals to P1, which is 0.92 times 10 raised to the power of 5 times V1, which is given as 850 times the value for T2, which is 273, all over P2, which is the value for the pressure at STP 0.01 times 10 raised to the power of 5 times T1, which is 320. So from here, we say V2 equal to, in my classes, I will also be guiding students on how to make use of our calculator. Sometimes we know how to solve a problem, but the use of the calculator is usually a challenge. So when students have questions like this, usually to be on the safer side, I advise my students to always start from the numbers at the numerator. You get your answer, you get the value for denominator. When you get the two answers, then you can divide. But not putting all the numbers all through in the calculator. Sometimes if you're not careful, you might likely not arrive at the correct answer. So now let's do this together, viewers. So we have 0.92 times 10 to the power of 5 times 850 times 273. Okay, so we have this, and this gives us a value of 2.13486 times 10 to the power of 10 all over. Now let's calculate what we have at the denominator, which is 1.01 times 10 to the power of 5 times 320. So here, what we have from the calculator is 32320000. So from here, all we need to do is to take the value we have at the numerator, that is 2.13486 times 10 to the power of 10, and then we divide by what we have at the denominator and get our answer. And this gives us a value of 660.54 centimeter cube. So we took this to two decimal places. So the volume of the gas as SCP is 660.54. Or depending on what we're given from the question, if it's an objective question, they can, decide to take the value to the nearest whole number. So viewers, thank you for watching. God bless you. See you in my next class.